welcome to my channel, and this is the most important video for today. And here is the, in my previous video there was some problem for some question for the joint IIT and advanced, and part of question is here, and this is 36, 37, 38, 39, 40 and 41. And see, in the question of 36 it is about the tangent normal. Now you have to introduce some point about tangent normal, what is tangent and what is normal. About that, this problem is very interesting question, and it is a very interesting and vital question for the advance of IIT. Okay, and see carefully. And first I introduce some basic concept of the tangent. And see, it is a curve like x square plus y square equal to a square, and this is the curve. So this is called the tangent. Okay, this is called the tangent at point x1 comma y1. And how could I find the equation of the tangent? And for that we have this is equation and differentiate this. So this is here 2y dy by dx, and this is 0. So now this is dy by dx is equal to x by y at point x1 y1. If you use the coordinate at that point, and we get the slope of the tangent, we get the slope, and this is called the slope of the tangent. Okay, and therefore the equation of a line, therefore the equation of a tangent you can write here. Therefore the equation of the tangent at x1 y1 is y minus y1 minus x1 y1 and x minus x1. Okay, now multiply by y1, y1, and this is here y1 square minus x1 plus x1 square. So we get here x1 square and y square, y1 square. As the curve contains the point x1 y1, so we can write here x1 square y1 square equal to a square. So we can write here a square. So this is the equation of the tangent. So this method we can easily find the equation of the tangent. And about this concept we have to find the tangent and what happened, see in this question. See about the 36. Okay, and this point of view very interesting. The tangent at point P of the curve y equal to x cube meet again P2. Again the tangent at P2, the curve meet again P3, and so on, except 0, 0. And see, in this curve like the point 0, 0, actually omit this point 0, 0. Then show that the abscissa of the point P1, P2, P3, the abscissa means this is the x1, x2, x3 like that. These all are in GP you have to show. And also find the value of area of the triangle P1, P2, P3 and divided by area of the triangle P4, P2 and P3. Okay, and what is the value? I think this is the value is would be 1 by 16 actually. Now see here, this is the curve y equal to x cube, and differentiate dy dx is equal to 3x square at the point dy dx x1 comma y1, and that is 3x1 square. Therefore the equation of the tangent at x1 comma y1 is y minus y1, and this is the slope we can use there as a slope. Dy by dx means this is the slope of the tangent, and x minus x1. Again this line meet the curve x2 and y2. Again this line, this is square, and this line again this tangent meet at the point x2 comma y2. Okay, and that is P2 here. This is P2. We can use here P2, and that is P1. So meet at P2. Then okay, now if we satisfy the point P1, then we get here y1 is equal to x1 cube, y2 is equal to x2 cube, and we substitute these 2 points in this equation, that is y2 minus y1, and this is x1 square, this is x2 minus x1, and put here x2 cube minus x1 cube minus 3 x1 x2 minus x1 equal to 0. So factorize this, that is x2 minus x1, and this is x2 square, x1 x2 plus x1 square minus 3 x1 square and x2 minus x1 equal to 0. So we have take a common x2 minus x1, then we have left here x2 square, x1 square, x1 x2 minus 3 x1 square equal to 0, but x2 never be x1, so we can take this factor x2 plus plus x1 and x2 minus 2 x1 square equal to 0, and factorize this 2x1 and x2 minus x1 x2 2x1 square equal to 0, and this is x2 2x1, this is x1 x equals to x1 equal to 0. So again x2 minus x1 and x2 plus 2x2, this is x1 equal to 0, but x2 never be x1, therefore x2 is equal to minus twice x1. Okay, similarly we can write here x3 is equal to minus 2 x2 and x4 is equal to minus 2 x3. So therefore, and this is here x2 by x1, and that is equal to x3 by x2, and that is equal to x4 by x3, and dot dot xn by xn minus 1 is equal to minus 2. Therefore x1 comma x2 comma x3 dot dot xn are in GP. So this is proved. Okay, now we have to find the value of del okay actually del P1 P2 and P3, area of the triangle P1 P2 P3, that is half of x1 1 2 3 1 2 3 y2 minus y3, again 2 x2 we get a y3 minus y1, and x3 we get here a 1 2 y1 minus y2, and now we have find, and this is here x1 y2, and this is here x2 cube x3 cube, and this is x2 y3 cube means x3 cube x1 cube x3, this is x1 cube and x2 cube. Okay, simplify this, and for factorization we can write here this is x1. You can write here x1 x2 q minus x3 q. Multiply these two factors, x2 x3 q, x2 x1 q, x3 x1 q, and x3 x3 q. Okay, this is here x1 x2 minus x3 and the factor sorry, x2 square x3 square plus x2 x3. Okay, after that, in between these two factors, take a common x2 and x3. This is x3 minus x2, and remaining these two are x1 q, and that is x3 minus x2. Okay, and factorize this. We have to take a common x3 minus 3 minus 2, and this also 3 minus 2. We take a common these 3, and this is your x3 minus x2 and half of that. And now minus x1 x2 square minus x1 x3 square minus x1 x2 x3. Okay, actually this is square. If we take a common x2 and x3, then x3 square minus x2 square. Okay, and then multiply by this is x2 x3 x3 square plus x2 x3 x3 square. Then after x1 cube, this is half of x3 minus x2. Okay, if we take a common this is x1, so x1 square minus x2 square. Okay, then after 1 and this, take a common x3 square. So this is your x1 minus x2, and we have left these two factor, that is x2 and x3, and this is your minus, so x1 minus x2. Then again write here x3 minus x2 and x1 minus x2, that is x1 into x1 plus x2. So we can write here x1 square plus x1 and x2 minus x3 square minus x2 x3, 3 2 x1 minus x2 these two x1 minus x3, and take a common here x2, so x1 minus x3. Okay, then half of x3 minus x2, x1 minus x2, x1 minus x3, and x1 square x1 plus x3 plus x2. Okay, systematically we want to arrange 1 2, उसके बाद 2 3, उसके बाद 3 1. Actually 1 2 3. About that 1 2. This is 1 2. Okay. 2 3. This is 2 3. Take a common minus. 2 3. Then 3 1. Take a common minus again. 3 1. So we can write as x2, x3, x2. Okay. Similarly, del, that is p4, p2, p3, that is half of 4 2 3. So from that you can write here x4 minus x2, then 2 3, x2 minus x3, then 3 4, x3 minus x4, and sum of that 2 3 and 4. Dividing this, therefore del p1 p2 p3 whole divided by del p4 p2 and p3. So half and half is cancel. This is would be a x minus x2, x2 minus x3. So half and half would be a cancel, and now these two factors is cancel. So 3 4, 1 or 2. This is okay, numerator part. In this is here x1 minus x2, x3 minus x1, 1 2 and 3. This is here x4 minus x2, x3 minus x4, 2 3 and 4. So this is your x2. So you can write here x1 minus minus plus 2x1, and this is your x3. In case of x3, we can write here minus 2x1 x3. This is x1 x2. x2 means here, oh actually this is x3. This is here x3. x3 means minus 2x2 minus x1. Okay, and now x1. x2 means this is minus twice x1, and x3 means minus 2x2. Okay, this is why x4. This is minus 2x3 minus x2. x3 means this is a minus 2x2 x3 minus minus plus 2x3 x2 x3. This is 2x2. This is 2x3. Okay, and this is equal to, this is here 3x1 x2. x2 means minus minus plus 4x1 minus x1. This is minus x1 minus minus plus 4 x1. This is and this is here 4x2 minus x2. This is here 3x3 and this is here minus x2 plus 4x2. So see 3x1 3x1 3x1. Okay, now this is 3x2. In case of x2 we can put here 2x1. Okay, and 3x3 we can put here minus 2x2, and this is here 3x2 minus 6x1. Okay, and this is 27x1 x1. This is 6 cube and x1, and this is here minus 2x1. Again this is here x1. I think okay. One, two, three. So 1 minus is left. So this is a cancel. So 3q are cancel. 3q8 to just 16. This is 1 by 16. Very interesting question, students. See carefully. I think all of you have better understood this question. Very interesting question. Okay. Now follow the 37, and also this question are given the math honors examination in Calcutta University. And now see the 37 question. Okay, see 37. And see here, this is a circle and this is a line. Find the x cos theta y sin theta is equal to p, so that the equation of a circle whose diameter is this as a chord of the circle of that. Okay, actually this is your circle, that is x square plus y square equal to a square, and this is a chord. Okay, that is x cos theta y sin theta is equal to p. Find the equation of a circle. Whereas this line as a diameter, then find that equation. Okay, like this. Okay, so okay, drawing is not so good. Okay. So given circle is this, that is x square plus y square equal to a square, and this is chord x cos theta plus y sin theta is equal to p. Okay, and find the equation of a circle whose this straight line has a diameter. You have to find this circle. Okay, and from that let us assume a circle. Therefore azimuth circle through these two equation, x square plus y square minus a square, and this is k times of this chord, and this is of the new circle as a diameter. This line in the new circle as a diameter. Now we have to find the center of this circle. Then we can we have to find the center of this circle and put this equation as it is a diameter. So diameter would be satisfied the center of that circle. Now see x square plus y square. So that is k cos theta into x, k sin theta into y, minus a square minus pk equal to 0. So center B, that is minus z, minus k cos theta by 2 minus k sin theta by 2, and this point satisfies this line as this is the center of this is okay, and satisfy this chord, minus k cos theta by 2 minus k sin theta by 2. Okay, satisfy this line. This point lies on the line x cos theta y sin theta is equal to p. Then k cos theta by 2 in place of x, and this is cos theta, same as minus k sin theta by 2 into sin theta equal to p. This is k by 2. So this is your cos square theta, sin square theta is equal to p. Now this is, and k is equal to minus 2p. So therefore the required equation of this circle is x square plus y square minus a square, and k means this is minus 2p times of x cos theta y sin theta minus p equal to 0. See, this is your answer. Okay, I think all of you have understood. Very interesting question. Now follow the 38 and this is 38 and this is 37, and see you are given here log tan beta and cos beta plus log sin beta and cot beta equal to 0. So implies that log tan beta cot beta log tan beta to the power minus 1 sin beta equal to 0. So implies that log tan beta cos beta minus equal to, you can write log tan beta sin beta, as the figure ascends so b is ascending, therefore you can write here cos beta is equal to sin beta. Okay, so it is B option. Okay, follow the 39. Sorry, 39. The equation is log x base 21 whole square minus log x base 81 plus log e base 81 equal to 0. With real coefficient, we will have exactly one solution. We will have exactly one solution. And the number of real solution of p, exactly one for for our one solution, we can write here as a quadratic equation of log x to the base 81, that is b square, means b square minus 4ac, 4ac a and c is log p 81 equal to 0. So 4 log p, b square minus 4ac 81 is equal to 1. So this is, and this is log p to the power 4, 81 is equal to 1. So p to the power 4 is equal to 81. So p square minus 9 and p square plus 9. Okay, 9. P square plus 9 never is 0. So p square minus 9 equal to 0. So p is equal to plus minus 3. But in case of log p, p never be negative. Therefore, p is equal to 3 as a single solution. As a single solution. So this is option A. First 41, then 40. Where I do this question. Okay. Now 41. Given that the log 12 base 27 is equal to 1 by x, actually, then we have find the value of log 16 to the power 6. And see here for that log 27 to the base 12, these are changes. This is, then this is equal to x, and this is 3q. So 3 log 312 is equal to the base 12 is x. So log 3 base 12 is equal to x by 3. So then log 12 base 3, we can write here 3 by x. So from that 12, 4 base 3, log 3 base 3 and 3 by x. So this is here 2 log 2 base 3 and this is 1, 3 by x minus 1. And check it, and this is here, okay. This is 3 to 3 are changes, and 3 by 3, and this is okay. And now log 12 base 3, this is 3 by x, and 12 means 4 to the 3, 4 3 the 12, and 4 3, okay, to the base 3. Log 3 base 6 is 1, or 1 is changes this, and okay. And this is your log 2 base 3 equal to half. Take a LCM 3 minus x. Okay. Now find the value of log 16 to the base 6. Okay, this is 16 base 6. 16 means 2 to the power 4. 4 log 2 base 6. This is 4 by 6 base 2. We can write here 4 by log 2 base 2 and log 3 base 2. So this is here 1 plus, this is 2 base 3 and this is 3 base 2. Okay, see with that, so we can write here 2x on the numerator by 3 minus x. Take a LCM. This is here 4 times of 3 minus x. This is 3 minus x plus twice x. 4 times of 3 minus x. This is 3 plus x. So 4 times of, okay, is by 3, but compare with that, so none. Okay, see the calculation here. Okay. Now next question is 40. Next question is 40. I think already better understood all this question. Now follow the 40. Okay. Log 2 that is 3. Log 9 half plus 9 to the power x equal to twice x. Okay, so from that log x plus 9 plus half plus 9 to the power x is equal to 3 to the power twice x. So log x plus 9 plus half, and this is 3 square, meaning this is 2x, and 3 to the power 2x. Okay, log x plus 9 equal to minus half. Log x is equal to 9 to the power minus half, 9 to the power half, and this is 3. So x is 3. Sorry, 1 by 3, option D. Okay, I think already you have better understood this. This is a very interesting video for this class, and I'll see the next problem on my next video. Okay, bye everybody.